Hi everyone, we can discuss about a PLA control and microprogram control in this video. In last class we have discussed about control logic design and what are the methods of control logic design. There are four methods for control logic design. One is one flip-flop per state method, and second one a sequence register and decoder method, third one PLA control, and fourth one microprogram control. So in this video we can see a third and fourth method, that is PLA control and microprogram control. So moving on to PLA control, what do you mean by a PLA control logic? First two methods, that is one flip-flop per state method and sequence register and decoder method, they are known as hardwired control unit because they use SSI and MSI devices. Also a large number of wired connection is possible there. But in the case of third method and fourth method, that is PLA control and microprogram control, which uses LSI devices to implement. In PLA control, it is a programmable logic array, which is actually similar to sequence register and decoder method, but the difference is all the combinational circuits are implemented with the PLA, including the decoder and decision logic. So in PLA control method, all the combinational circuits, including the decoder and the decision logic, are implemented with the PLA. PLA is a programmable logic array. So by using this PLA for the combinational circuits, it is possible to reduce the number of integrated circuits or the number of interconnection wires. That is the main advantage of PLA control. So PLA control logic, it is a programmable logic array control unit. It is implemented with PLA, including the decoder and decision logic. And the main advantage for the PLA control is it reduces the number of integrated circuits as well as the number of interconnection wires. And this is the architecture of PLA control logic. So in this there are two main components are there. One is a sequence register and other one is a PLA. PLA, programmable logic array. And the sequence register, it is similar to sequence register that is present in the second method, that is sequence register and decoder method. In this architecture, PLA is actually a combination of a decoder and decision logic that is present in the second method. Clear? So PLA, which access external input condition as well as output of the sequence register, and then initiate some micro operations. What do you mean by a micro operation? Micro operation is an operation that is performed on the data that is present in the registers. Okay, so output of PLA is micro operations, and they accept external input conditions as well as the output of sequence register. PLA is actually an LSI device, so that's why they can implement any complex combinational circuit. Here there is an external sequence register is there. They represent the present state of the control unit, and the PLA output determines which micro operation should be initiated, and it depends on the external input condition and the present state of the sequence register. Okay, and other PLA outputs which determines the next states of the sequence register. So these are all about PLA control. So PLA control, it is an LSI device. It is a third method for control logic design, in which the decoder and the decision logic is implemented with a PLA along with a sequence register is the This sequence register establishes the present state of the control circuit. By using the external input condition and the present state of the sequence register, PLA generates micro operations. Clear? And next is a microprogram control. This is the fourth method of control logic design. So the purpose of this control unit is to initiate some micro operations. So it is actually a micro instruction, or it's otherwise known as a control word, which is a combination of strings of 1 and 0. And all these control words are stored in a control memory, that is a microprogrammed control memory, and each control word is known as micro instruction, and the sequences of micro instruction is called a microprogram. Okay, so this is an architecture of a microprogram control. Here there are three main components are there. One is next address generator, second one control address register, and third one control memory, that is a ROM memory. So purpose of this control unit is to initiate some micro operations. Okay, control unit which initiates some micro operations. Okay, and here there are three components: next address generator, control address register, and control memory is there. And the content of this control memory is actually known as a control word, or it is otherwise known as a micro instruction. And these micro instruction, sequences of these micro instructions are known as a microprogram, and which initiates micro operations. And these micro operations, which output of the control memory is fed back to next address register, and this next address register which also access external input conditions. Okay, so in microprogram control there are three components. One is next address register, generator, control address register, and control memory. Here the control memory can be a ROM. So content of ROM means they are the control words, or it is otherwise known as micro instructions. And the output of control memory is it's a micro operation, or the micro instruction which initiates some micro operations. And what is the use of control address register, which stores the addresses of the control word? It's a type of register which stores the address of control word. What is a control word? Control word is a micro instruction that is present in the control memory. So control memory il store ചെയ്തിരിക്കുന്ന micro instructions inde അഥവാ control word inde address ആണ് control address register il ഉണ്ടാവുക. Okay, here there is no read signal is needed. And what is the use of next address generator? Next address generator which generates next address by using external input conditions as well as the output of control memory. Okay, these are all about microprogram control. Thank you.